Now, let's get a little bit more work done with some adjacency matrices, just so you can get a bit more comfortable. So let's talk about inverse graphs. In the unit, we discussed how to create the inverse graph of a graph that helped us solve the click problem. So for example, the inverse graph of the graph that I drew before would be the graph with the red edges here. So quite a different graph here. Now, how would we represent this as an adjacency matrix? Well, the diagonal is the same because we're not allowing loops anywhere in here. So the diagonal is still zeros. And the only ones we have in the adjacency matrix are from D to A, or from A to D, since the matrix is symmetric, and from B to D. And everything else is zero because all of these edges disappear in the inverse graph. Now, how would we represent this in Python? Well, an easy way to represent a matrix in Python is as a list of lists. So to look at some output of some code, we define a completely empty graph here, and then we print the graph. We see that this is just a list of lists with 5 zeros in each inner list. And if we invert this graph, then we see that we get the graph of all ones, except for the diagonal here, of course, since we don't allow loops. So what I want you to do is write an inverse graph function such that it takes a graph or a list of lists and outputs a list of lists, which is the inverse of the input graph.